Right, so in this video we're going to have a look at the Junior Cert Higher Level Maths Paper 1 for 2017, and in particular I'm going to have a look at questions 8 and 9. So the first part of this is to do with a school, and it gets its electricity from one of two companies. They're called Buzz and Lecky. The graphs below show the cost of electricity per month from each company if the school uses X units of electricity. The cost for Buzz is represented by B of X, that's here, and the cost from Lecky is L of X, which is this one here. So you can see the two graphs here. One is a straight line, and one kind of goes up sharply and then levels off. One starts at 0, the other starts here at 50. So this would mean this one here means that you would have to pay 50 euros even if you use no units of electricity, whereas this one here, the L of X one, is you just pay for the units that you actually use, but it does rise a lot steeper here at the beginning anyway. So let's have a look at the types of questions we're going to be asked. Let's see. One of the companies charges a fixed fee each month plus a fee for each unit of electricity used. State which company charges no fixed fee. Give a reason for your answer based on the graph. Well, the one that charges no fixed fee here is the L of X. This is Lecky here, because for no units used you pay 0. So it's what's it called, L of X, which is Lecky, I think it is, yeah. So let's just write that down. So the answer then here is which company charges no fixed fee? This is Lecky, and the reason for 0 units used, the school pays 0 euros since so for 0 units used here, the school would pay 0 euros. So they don't pay anything if they don't use any electricity. Write down the domain and the range of the function b of x as shown on the diagram. The domain and the range of b of x. So b of x here is this straight line. Now the domain then is they're the set of inputs. So the set of inputs here would be from 0 up to, you can see here, 1,000. So from 0 up to 1,000. So the set of inputs would be, let me just put that in here. So x would be greater than or equal to 0, less than or equal to 1,000. And these are euros, no, sorry, these are units. So these are units. So from 0 to 1,000. The range then, they're the set of outputs. So the set of outputs would be on the y-axis here. So y would start at 50 and finish here at 300, and this is 350 here, so this is 325 here. So we're starting at 50 and finishing at 325. So let's just put those in. So y would be greater than or equal to 50 and less than or equal to 325, and these are euros here. This is euros. Okay, so that's our domain, that's our range for b of x. Use the graph to estimate the set of values of x for which b of x is less than L of x. So again, if we look at our graph here, we want to know where b of x here is less than L of x. Well, it's less than it from here to here. All of these y values will be less than all of these y values here for L of x. So they want the set of x values for these values here. So it's here, that would be 100 up to 800. 100 up to 800. So we're talking about, we would write it like this, we would talk about the set. They're wanting x values here, remember. Use the graph to estimate the set of x values. So x here would be greater than 100 and less than 800. So again, just to show you that here. So this would be 100 here. So it's greater than, it doesn't include this one because it's not less than b of x here, it's equal to it. So here we would just write down greater than 100 and less than 800. So all these x values in here will give us this set of values here. Okay, so let's move on. I'll just put a little squiggly bracket around this. Explain what your answer to part C1 means about the cost of electricity from Buzz and Lecky. What does this actually mean? Well, again, to go back to the graph here, it would mean that if you are to use 100 units up to 800 units, you're better off going with Buzz because the cost will be lower. The cost will be lower if you use between 100 and 800 units of electricity. If you use greater than 800 units of electricity, you can see that the cost is going to be more expensive than Lecky, and if you use less than 100 units, the cost is going to be more expensive than Lecky here. So that's really all it means. So let's just put that in there. So if the school uses between 100 and 800 units of electricity, Buzz will be cheaper. And Lecky. Okay, so next one then, find the slope of the graph b of x. So find the slope of the graph b of x. So again, to go back up here, b of x is a straight line, so we can find the slope of this. So what do we need to find the slope of a straight line? Well, we need 2 points. Now the 2 points I'm going to use are the 2 points at the ends of the line. So I'm going to use this one here, this point here, which has coordinates 0, 50. I'm also going to use this point up here, which has coordinates 1000, and over here we've got 325. So they're the 2 points I'm going to use. So let's go down here and do that. Well, to find the slope of a straight line, we have a slope formula. We know that m is equal to y2 minus y1 over x2 minus x1. The difference of the y's over the difference of the x's, or the rise over the run. Now our 2 points are, what did I say, 0 and 50 was 1 point, and the other point was 1000 and 325, I think it was, yeah. So let's say this is my x1, this is y1, this is x2, this is y2. So all we got to do is stick these into our formula, and that will give us our slope. So we got y2, which is 325 minus 50 over 1000 minus 0. So that will give me 275 on the top. We'll get 1000 on the bottom. So that will give me a slope of 0.275. So there's my slope for the straight line. What does this actually mean? Explain what your answer to part D1 means about the cost of electricity from buzz. Well, what the slope means is it's really how the y-axis compares to 1 unit of what's on the x-axis. So in other words, in this case, on our y-axis we have cost. On our x-axis, again, if you look at the graph here, on our y-axis we have cost. On our x-axis we have number of units used. So it's the cost per unit. It's the cost per 1 unit. And we got, what did we get? 0.275. So what it means is that it costs 0.275 euros per unit of electricity. And that's it for question 8. Question 9 then, this is to do with, let me see, oh yeah, we have a quadratic equation here. We have to solve it, so in other words find what x is and give your answer in this format here. So seeing that we need the format a plus or minus the square root of b would indicate that the way you would solve this is just simply use the quadratic formula method. So if you remember to use that, it's x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now in our case, let's see, a is going to be equal to 1, b is going to be equal to minus 2, c is going to be equal to minus 4. So there are 3 values that we need to put in here. So x is going to be equal to minus b, which is minus minus 2, which is 2, plus or minus the square root of b squared, so it's going to be minus 2 squared minus 4 times a, which is 1, c, which is minus 4, all over twice a, which is 1. So we end up with 2 plus or minus the square root of minus 2 squared is 4, minus times minus is plus. 4 4s will give me 16, and here I'll end up with 2 on the bottom here. So this gives me 2 plus or minus the square root of 20 over 2. So this will give me 2 roots or 2 solutions here. 2 plus root 20 over 2, or 2 minus root 20 over 2. Now we were asked to give these roots in a particular format, a plus or minus the square root of b. So if you take square root of 20, if I just look at the square root of 20, that's going to be the square root of 4 times 5. So that's the square root of 4 times the square root of 5. Square root of 4 is 2, so that's 2 root 5. Your calculator will do this for you as well anyway. So what we end up with here is x is equal to 2 plus 2 root 5 over 2, or 2 minus 2 root 5 over 2. So here you divide the 2 into the 2 and the 2 into this. So you must divide it into both here because you got a plus in the middle. If it was multiplied here, if that was multiplied for some reason, then you would just divide the 2 into one of them. But because it's added or subtracted, you must divide this 2 into both. So 2 into 2 was 1. 2 into 2 here is 1, and we just get root 5. Or 2 into 2 is 1 minus root 5 here. So these are our 2 answers. So really our x is, we got to write it the way they asked us. So x is equal to 1 plus or minus root 5. Okay, so that's that one done. Let's move on to the next part then. Given that d squared is equal to given that the square root of d squared is equal to d, multiply out and simplify. So we have to multiply this out. C plus root d squared, which is just c plus root d is again. We're just multiplying it by itself. So let's do this the kind of long-winded way. So we take the c here, multiply it by the second bracket, c plus root d. Then we take the second part here, which is plus root d, multiply that by the second bracket, c plus root d. Let's multiply it out, c times c, c squared. C times root d is c root d. C times root d is c root d. Root d times root d is root d squared. And we were told here that root d squared is just d. Okay, so now we end up with c squared. We have a c root d plus a c root d. That's 2 c root d's. And then we end up with d here. So that's it. That's just those two multiplied out, or this thing squared here. I don't think we can do anything more with that. So let's move on. So last part of this question then is to do with this table here. And it shows whether each of the given numbers is an element of a natural number, an integer, a z, or rational number q, or an irrational number. They're all the real numbers minus all the rational numbers. Complete the table by writing yes or no into each box. One row is already done for you. 16 is an element of n. It's a natural number. It's also an integer. It's also a rational number, but it's not an irrational number. A number is either rational or irrational. It can't really be both. So let's just fill out the other ones. Okay, so the square root of 6. The square root of 6 is not a natural number. It's not a whole number, so we put no in there. It's not an integer. It's not a whole number, so it can't be an integer. Is it a rational number or an irrational number? Well, the square root of 6 is it's made up of the square root of 2 times 3, square root of 2 times square root of 3. These are both prime numbers, which are, and the square root of which are irrational numbers. So the square root of 6 is actually an irrational number. So it's not rational, but it is irrational. Now what about 2/3 here? 2/3 is not a whole number, so it can't be a natural number or an integer. It is a rational number. You can express, it is a fraction in fact, where a and b, the top and the bottom, the numerator and the denominator, are both integers. So it is a rational number, so if it's rational it can't be irrational. What about -4? Well, -4 is not a natural number. It is a whole number, but natural numbers are positive, so it can't be a natural number. Is it an integer? Well, it is a whole number. It is a whole number, so it is an integer. Is it a rational number? Can you express it as a fraction? Yes, you can. -4/1. Is it an irrational number then? No. Okay, so that's it for these two questions, 8 and 9.